Welcome back to a brand new installment on lines and angles. Just a disclaimer, by no means this four-part series is comprehensive. That is, if you know these four videos, you know the concept of lines and angles. That's not the purpose. The purpose is just to understand how the idea of lines and angles, when they're fused together, what are the outcomes? Just to understand a different perspective of how these two work together. Right? I'll be making separate videos on lines and angles from various vantage points in the upcoming time. So without further delay, let's get started. So in the first problem, you're told you have a line segment AC, which contains points B and M, where M is a midpoint, right? And you're asked to determine a ray opposite to BC, and you're asked to determine the length of the line segment AM. First, let's understand a few things. What's a midpoint? A midpoint is a point which separates two other points by equal distance, right? So if you say M is midpoint of AC, that means line segment AM is equal to MC. In other words, these two have equal length. So if you say AM is 6 meters, then MC should also be 6 meters. That means AM should be AM plus MC, which would be 6 plus 6 equals 12 meters total. That's the whole purpose of midpoint, right? That's midpoint. Now, what's a ray? In a ray, there's a common point from which the line extends forever, right? So if you say what is a ray that's opposite to BC, that means the first letter is the anchoring point. It's like you tie a string to one end and then you extend the string in the opposite direction or in some direction, okay? So that means because C is, to the right of B, the arrow should be pointing from B towards C. Okay, now this is a ray because B is the anchor point. Now, what's critical about a ray that's opposite to BC is, if you notice, ray BC contains M as well, right? So when you draw a ray that's opposite to BC, it must contain B as the anchor point in the opposite direction, which means it cannot contain any points that are contained in BC. So what you have to watch out for when you're looking to determine an opposite ray is BC is the anchoring point, right? That means B is the anchoring point in the ray opposite as well. So you cannot go, you have to start from B and work in the opposite direction. So that means BA, right? Right? You're starting from B and the arrow is pointing towards A because that's the direction in which you're heading, right? So BC and BA are opposite rays, right? For one main reason is BA does not contain any of the points covered by BC, right? So the answer is BA, right? In other words, they both have a common anchoring point. If that's not there, even if there's a common anchoring point, but if one of the rays contains elements of another ray, then they cannot be opposite, even though the arrows might appear in the opposite direction. I have a magnificent problem in the next few slides. That one problem is enough to address the idea of rays, right? So if you know that problem, you can do pretty much any problem on the concept of rays. Without further delay, let's finish this problem. What's the length of AM? What is AM? AM is AB plus BM, right? You're asked to determine this line segment AM, right? And we already know BM is 6. And we're told AB is 2/3 of BC. Sorry, 2/3 of MC, right? But we don't know any information on MC. So the only way we can get rid of MC is to use the idea of midpoint where MC is equal to AM, right? So substitute for MC with AM. So that means AB should be 2/3 of AM, right? Now plug it back into AB, plug this back into this expression and solve for AM. So AM equals 2/3 of AM plus 6, right? If you subtract negative 2/3 AM on both sides, that will give you AM minus 2/3 of AM equals 6. That's essentially AM over 3 equals 6. If you multiply by 3 on both sides, AM equals 18. Does that make sense? Let's continue. There are two problems. One is very straightforward and the other one is rather tricky from only a time perspective. Now, if you have all the time in the world, you can probably figure out, okay, I did this wrong, let me go back and work it out. But when you're constrained for time, problem 2 may appear difficult simply because you just have the pressure to complete the problem. So here's how you do the first problem. You're told that Q is midpoint of PR. Right away, we know segment PQ is equal to segment QR, right? These two have equal lengths. And we are told PQ is x plus 3, and we are told QR is equal to 2x minus 1. You're asked to determine the length of the whole segment PR, right? So first, let's write a few things. PR is PQ plus QR, right? Essentially, your two segments add up to give the net segment PR. And PR is equal to PQ plus QR, right? So PQ plus QR is x plus 3, right? Plus 2x minus 1, right? Does that make sense? Okay. So we have to determine PR, but how are we going to determine unless we determine the value of x, we can't solve for PR, right? So that means, you know, the only way we can solve for the value of x is to use the idea of midpoint. That means x plus 3 equals 2x minus 1, right? So that means this would be what is it? X equals 4, right? Now we know value of x. So that means PR would be 4 plus 3 plus 2 times 4 minus 1. That will be 4 plus 3 is 7, plus 2 times 4 is 8, minus 1 is 7 as well. So that's 14. So the correct answer is 14. Okay. On the segment PS above, you're told PR is 12, QS is 16, and QR, this small segment right here, is 1/3 of PS, and you're asked to determine the length of the segment PS, right? So first, let's write PS as a combination of all of the individual segments, which would be PQ plus QR plus RS, right? So we know that QR is 1/3 of PS. Let's not focus too much on it just for time being. Let's see how we can determine PQ. What is PQ? Well, we don't know anything about PQ, right? But we know that PQ plus QR, right, is PR. We do know information about PR and we know information about QR. So let's write PQ as PR minus QR, which would be 16 minus 1/3 of PS. So now we know two terms. We know PQ, we know QR. Let's go ahead and do a similar math for RS. What is RS? That's essentially QR plus RS is QS. Why are we choosing these? Because we have to use only terms for which we have some information. You cannot have two unknown variables, right? Because we don't know RS, but we know QR and RS. So RS is QS minus QR, which again is, what is it? 16 minus 1/3 of PS, right? So now we know expressions for all three. So PS equals, PQ is 16 minus 1/3 PS, plus QR is just 1/3 PS, and RS is 16 minus 1/3 PS, right? We can simply cancel these out. So this would leave us with, sorry, this would be 12 minus, sorry, this is 12. That's why I was wondering. It appears odd. So this is 12 plus 16 is 28. Because I didn't remember using 2/16 when I solved the problem. And I didn't see 2/16 in the way I've written here. So that's 28 minus 1/3 PS equals PS, right? So if you add plus 1/3 PS on both sides, that means PS plus 1/3 PS equals 28. Implies this is 4 PS over 3 equals 28. So solve for PS, that will be 21. Sorry. So the problem is not difficult by any extent. I'm sure it's very easy, but when you're constrained for time and when you have to figure out all these bits and pieces, that's when the real trouble comes. So I highly recommend you practice this sort of problem so you know what to do when you're faced with this sort of situation where you're constrained for time. Right. This problem 3 is a magnificent demonstration on how you can handle rays, right? So the question is asking which of the following are opposite rays. So we can use the pairs provided and eliminate one at a time to understand the idea of rays better. I've explained what ray and how to do it in the very first problem, but let's understand it better through this problem. If you understand this problem better, then you're always going to get the idea of ray correct. All right, so ray A, B, and CD. When you say AB, right, that means A is a anchoring point and it's heading towards B, no problems. That's good. CD, okay, C is anchoring point, and from C you're heading in direction towards D. Well, the two arrows are in the same direction, so that means this is incorrect. Now keep in mind your A and your C are your anchoring points. It means that's where it's fixed. You're only heading in a direction indicated by the second letter. So AB means you're heading towards AB, CD means you're heading towards D, right? So that's incorrect because the two arrows are pointing in the same direction. CA and CD, right? So CA is, sorry, I should have written the arrow this way because C is anchoring point, right? And A is in this direction, so the arrow is here. Similarly, C is the anchoring point. I'm going to call it AP for anchoring point. And D is here, so we're clearly what you have to watch out for, CA contains B, right? Whereas CD does not contain any of the points shared by CA. So this is a candidate for correct answer. So let's put a question mark and let's continue. We have DA and AD. As I said, your anchoring points should be the same. DA means your anchoring point is D, and A means you're heading in this direction, right? You're heading towards A, right? Well, that's, yeah, just like how we did CA. So AD means A is the anchoring point, right? And you're heading towards D. Well, DA and AD share all the points. As I said, if two rays have to be equal, not only the arrows have to be pointing in different directions, but they must have same anchoring point. That's another criteria. On top of that, they cannot share any of the elements shared by one ray cannot contain elements that's present in the other ray as well. Clearly, this is violating on two counts, except the fact that the arrows are pointing in different directions. This does not have a same anchoring point, so it's already failed, but it also contains similar points. In other words, points are shared by both segments, so that's incorrect as well. So far we have only this. Then let's go to the final choice. We have segment CA. CA means we are heading in this direction, right? So C is the anchoring point and it contains point B, right? So this is the anchoring point and it contains point B. We have BD, B is anchoring point. Clearly it's failed on the anchoring point because C is anchoring point, B is anchoring point. That cannot be a ray because they should have same anchoring points, right? Or at least in this case, it's failing. So BD means it contains C as well, right? How can CA contains B, but how can an anchoring point be an element in the second ray? Does that make sense? That's why I keep saying it should have same anchoring point. And here, C is anchoring point, but in BD, C appears to be a point in the ray BD. That can be possible, so that's incorrect as well. So the correct answer is B, right? All right, let's finish up this video. In the figure about AB equals 2/3 of BC, what's the length of AC? First, we have to figure out what is AC. AC is AB plus BC, right? So AC is x plus 3 plus 3x minus 6, right? That's equal to AB plus BC. So BC is, well, first we have to convert this all into BC because, or into AB, doesn't matter. So AB is 2/3 of BC plus BC, right? That's essentially 5 BC over 3. That's equal to 4x plus 3, right? I just simplified this further. So if I multiply, again, let's substitute for BC as 3x minus 6 over 3. So if I multiply by 3 on both sides, that'll be 12x plus 9 equals, what is it, 15x minus 30, right? So that will be 3x equals 21, right? So yeah, 9 plus 30 is, did I do my math right? So this would be 3x, right? Sorry, I don't think I did that right. So that will be minus 30. So if I bring this side, it will be 39. So x would be 13, right? X is 13. So I did my math wrong. Sorry about that. So now we have to figure out AC. That means it's x plus 3. So 13 plus 3, right, which is 16. And 3 times 13 is 39 minus 6 is oops. Okay, this is 4x minus 3. So all of these are incorrect, right? So 4x minus 3, that's why it seems like it won't even add up to any of the answer choice here. So 4x minus 3 equals, let's redo this, equals 5 times 3x minus 6 over 3, right? So multiply by 3 on both sides would give you 12x minus 9 equals 15x minus 30. So that'll be 3x equals 21. So x equals 7, right? So if you substitute all of these into this expression, so 7 plus 3 times 7 minus 6. So that'll be, what is it, 10 plus 15, right? So 21 minus 6 is 15. So that's 25. I apologize for this little confusion. See, that's why I keep saying, despite your hard work, if you make like a calculation error that I did here, you're going to wonder, well, I don't even have an answer. The reason I figured out why I went wrong is because when I solved this, I would not have an even answer choice. That's what I determined my value of x to be. So that's why I figured, okay, I made a mistake somewhere, and then I noticed I made a mistake here. And I sincerely apologize for that. Please learn from me and don't make this sort of careless mistake. I don't make mistakes like this all the time, but I do make mistakes once in a while. So try to avoid mistakes at all costs if you want a really, really good score. So that's how you do this problem. Thank you for watching. I'll see you with another video on lines and angles. So stay tuned. Bye-bye.